explaining the sampling distribution of the sample mean, and later on I'll be discussing a problem about it. So what is a sampling distribution?
I don't know. What is it?
The sampling distribution is a probability distribution of a statistic that is obtained from a larger number of samples in a specific population. The sampling distribution of a given population is the distribution of frequencies of different outcomes that may occur for a statistic of a population. So to further explain the sampling distribution of the sample mean, my cartoon self is going to present the problem that I prepared. So take it away, my cartoon self.
Hey, why do you always make me explain the problems all the time? Why don't you do it?
I don't want to and I'm too lazy, so you do it.
Fine, okay. So, let's read the problem. Wait, let me just get ready. I'm just gonna go stand up. Okay. Alright, okay. Let's read the problem then. Suppose the population consists of 4 data, 2, 6, 4, and 8, and each has an equal probability to be chosen. Suppose the sample size of 2 is chosen from the population with replacement. A. Find the population mean and variance of the population. B. Find the probability distribution of the sample mean. And C. Find the sample mean and its variance. So let's start with answering letter A. We have to find the population mean and the variance of the population. We are given 4 data which consist of 2, 6, 4, and 8. I've categorized them like this to properly show where they're going to be placed in the formula. This is the formula that we are going to use. Mu, or the population mean, is equal to x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 over the number of data we are given, or population. Now we're going to fill up the formula with its values. This is going to be 2 plus 6 plus 4 plus 8 over 4. We add the numbers on the dividend and that gives us 20. After that, we divide 20 to 4 and that gives us 5. So now the population mean is 5. Now let's solve for the variance. The formula for this one is sigma squared, or the variance, is equal to x sub 1 squared plus x sub 2 squared plus x sub 3 squared plus x sub 4 squared over the number of data we are given, or population, and minus all of that to the population mean squared. So we put in the values and now it becomes 2 squared plus 6 squared plus 4 squared plus 8 squared over 4. Then minus all of that to 5 squared. We square all the numbers on the dividend. We also squared the 5, so it turns to 4 plus 36 plus 16 plus 64 over 4 minus 25. Now we add the ones in the dividend and it gives us 120. Then let's divide 120 to 4 and it gives us 30. 30 minus 25 is 5. Now we have the population variance, which is 5. Now we're done with letter A, so let's answer letter B. Here we have to find the probability distribution. But before we do that, we have to fill out the sampling distribution. This is what the sampling distribution would look like. The samples are filled out by all the possible sample sizes of 2. There are 16 samples in total. The mean below is solved by adding 2 sample size and divided by 2. Like this. We have 2 and 2 as our first sample, so we add 2 and 2 and divide it by 2. That gives us 4 over 2. And divide that and we get 2. So the mean for 2 and 2 is 2. After we find all the means for the sample, we can now fill out the probability distribution. What you put in the sample for the probability distribution are the numbers in the mean from the sampling distribution. Note that when a number repeats, you don't put it anymore. Here is the probability distribution. You solve for the mean for the probability distribution by dividing the number of times the mean from the sampling distribution was repeated to the number of samples from the sampling distribution. Like this one. 2 only came once in the mean for the sampling distribution. So that means we divide 1 to 16. So now this is our probability distribution. Okay, so now we are going to answer the last question. We are asked to find the sample mean and the variance of the sample mean. So let's start with finding the sample mean. The formula for this one is the sample mean is equal to the sum of all the means from the sampling distribution over the number of samples from the sampling distribution. Then we put all the values for the formula and it would look like this. We add all the numbers on the dividend, then we get 80. We divide 80 to 16 and we get 5. Just a side note, the sample mean and the population mean should always be the same. Lastly, we solve for the variance. This is the formula we are going to use. Var of the sample mean is equal to the summation of mean sub 1 from sampling distribution minus the sample mean, and all of that is squared, over the number of samples from the sampling distribution. So after you solve the mean sub 1, you go and change it to mean sub 2, and then you minus it to the sample mean again. So we have like 16 means, so you have to repeat that like 16 times. Yeah, and don't forget to square them because I usually forget to square them. So yeah. After doing all that 16 times, it would look like this. It should look like this. So yeah. First, we have to solve the one inside the parenthesis. So after we solve that, we square each one, and then we now add them all and we divide it by 16. So after adding them, we get 40. So now we do 40 over 16 and we get 2.5. So 2.5 is the variance of the sample mean. Here are all the answers for all the questions. Yeah, now go back to that lazy bones over there. She's gonna do the closing for this video.
Thanks for explaining the problem for me, Cartoon Self.
Yeah, whatever.
That's the end of the video. Thanks for watching and goodbye.